Good morning. Welcome to Mission Control Houston and the International Space Station Flight Control Team. This is the spot where a team of specialists is on duty around the clock to help the space station crew members with their daily science and maintenance tasks while keeping an eye out for the operation of all of the space station's systems. Now, this week, the teams here worked on laboratory science, on preparations for the launch of the next shipment of supplies and the next spacewalks on the agenda, and they also hosted a visit by a member of President Trump's White House team.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire. This week, Senior Advisor to the President, Ivanka Trump, visited Johnson Space Center to tour key human spaceflight facilities and meet with students. During her visit, Ms. Trump and NASA Administrator Jim Bridenstine toured a mock-up of the space station and NASA's Orion spacecraft. She also met local high school students working with NASA engineers to build a robot for the first robotics competition. While visiting the International Space Station Flight Control Room, Ms. Trump spoke with astronauts currently on board.
Do you have anything you want to share with us about your experience at the International Space Station as astronaut?
I'd say our message is pretty consistent. We all believe in what we're doing up here. We think it's important to the continuation of the human species, and also the science that we're doing in space is all really designed to make life better on Earth and allow us to be better as people as we take care of the planet and also move out into the solar system.
Astronauts on the space station checked out their spacesuits in preparation for some outside exploration. NASA astronauts Serena Anand-Chancellor and Drew Feustel joined European Space Agency astronaut Alexander Gerst to inspect spacesuits ahead of upcoming spacewalks. The astronauts ensured the correct sizing of the suits, which will be used when they venture outside of the Quest airlock to upgrade batteries on the space station's truss structure. Visit our website for launch schedule updates and to watch live. This week's question is about the upcoming spacewalks, specifically what will happen to the old batteries once they're switched out. Just like old batteries in your household items, these will be disposed. The lithium-ion batteries being delivered on the Japanese cargo vehicle will replace 12 nickel-hydrogen batteries on the port truss. Once the swaps are complete, 9 of the older batteries will be stored in the Japanese cargo vehicle to be disposed of in the atmosphere upon re-entry. The remaining 3 will be stored on the station's truss permanently, but not as spares. After the upcoming spacewalks to replace the batteries are completed, 4 of 8 power channels on the station will have been upgraded with the new batteries. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
The Japan Aerospace Exploration Agency is moving ahead with plans to launch an HTV cargo ship to the station with more than 5 tons of experiments, supplies, and spare parts this Saturday. And our live coverage of the launch begins at 12:30 Houston time tomorrow afternoon, September 22nd, on NASA TV and nasa.gov. Liftoff from the Tanegashima Space Center is targeted at 12:52 Central Time Saturday afternoon. That will lead to a rendezvous at the station on Thursday, September 27th. And our live coverage of grapple operations starts at 5:30 Houston time Thursday morning. Capture is expected at 6:54, and then we'll be back at 9:30 to watch Canadarm2 berth the Japanese cargo ship to the Harmony module. Whether it's a cargo ship launch or a crew launching and landing, or a spacewalk, or whatever operation you want to talk about, it takes quite a team to ensure that space station operations run smoothly. The lead flight control team for the International Space Station works right here in Houston, and the flight director holds the overall responsibility to manage and carry out all human spaceflight missions, coordinating NASA's work with that of all of the partner agencies. Earlier this summer, NASA named 6 men and women who are now training to join the flight director team. Japan's Kanatori cargo ships are a good example of the cooperation in space that the International Space Station encourages, and that's both in operations and in science. Recently, NASA announced the continuation of its successful collaboration with JAXA by signing an agreement to encourage scientists from both countries to use International Space Station hardware that's located in both countries' laboratories.
Booster ignition and liftoff of Shuttle Discovery. Gambate kudasai. Best of luck to the International Space Station's newest laboratory.
Since Kibo is in operation in 2008, we conducted about 100 of experiments was conducted. Through this partnership program with the US, we are trying to invite Asian Pacific area countries to ISS program. And also we are open for any collaboration framework with the other countries. That's the way we will maximize the outcome and give back the benefit for the humankind.
The laboratories on the International Space Station provide a setting for scientists to do experiments that take the force of gravity out of the equation. And that means they can do experiments on orbit that they cannot do on Earth. For example, there's an experiment underway that's studying sediments of quartz and clay, focusing on the forces between particles that cluster together. And that could have an important impact on technological efforts related to deep-sea hydrocarbon drilling and carbon dioxide sequestration. Being in the microgravity environment of Earth orbit for a long period of time causes changes to an astronaut's musculoskeletal system. That includes muscle and bone weakness and bone density loss. With that in mind, there's a medical breakthrough aimed at rebuilding bone and maybe blocking bone loss that's now being investigated on the station. UCLA researcher Chia Su explains some recent success testing a new drug on Earth to grow bone, and talks about what she and her colleagues hope to learn through research in microgravity. Could be therapies developed that have the potential to benefit millions of patients worldwide suffering with osteoporosis, extended bed rest, and other symptoms.
One of the projects we're working on is how to better grow bone, both on Earth and in space. Part of our project for bone regeneration is asking the question, how does Mother Nature grow bone? Osteoporosis, as you may know, is a huge, huge problem. So if you imagine on Earth, after the age of 50, you lose about half a percent of your bone mass per year. But in space, the astronauts under microgravity conditions can lose about 1.5% per month. So that has enormous implications for longer-term spaceflight. Now that we have this molecule, we know it forms bone. The thing is, how can we make it work in space? Microgravity really offers a unique situation. What we hope to learn is that this molecule can help reduce bone loss and maybe restore lost bone. We've been doing a lot of testing on Earth now to perfect everything. We've identified the function, modified it to make it last longer, and so we've shown that it very significantly promotes bone growth in osteoporotic models. So it really offers a unique experimental system you can't recreate on Earth.
Astronauts on the station support all kinds of scientific research in the laboratories, but they also work daily to maintain station systems to support that science. During this year of education on station, the NASA astronauts are also doing experiments for the benefit of school students on Earth to help them in their studies of science, technology, engineering, and math. Flight engineer Ricky Arnold added a demonstration video to the collection that gives us a unique look at how the molecules that make up water behave in space.
Welcome to the International Space Station. I'm NASA astronaut Ricky Arnold. Our view from the ISS of Earth is absolutely magnificent, but we quickly realized we really should call it planet Ocean. We are mostly a water planet. Water occurs here in all three phases, solid, liquid, and gas. And the presence of water on other planets and moons within our own solar system has us wondering, is there life there too? Well, why is water so special? One reason is called surface tension. So what is surface tension? Let's have a look. Surface tension is a property of liquids in which molecules of one substance are more attracted to each other than to molecules of another substance. Water is unique in that it has a high surface tension compared to other liquids. This is due to its polar property. The positive hydrogen ends and the negative oxygen ends create a strong bond. As they say, opposites attract. So the hydrogen end of the water tends to stick to the oxygen end in a nearby water molecule. At water's surface, its molecules are only attracted to the water molecules below and to the sides of them, as there is only air above these molecules. So the surface molecules of a body of water are pulled down, creating a more stable, stronger environment. That is why certain animals, like the water strider, can actually walk on the surface of water. Here on the International Space Station, the microgravity environment makes it easy to show how well water uses surface tension to stick together. We even rely on surface tension to help us wash our hair, those of us that have a lot. Thanks for coming along today and learning a little bit about surface tension. Want to learn more about the unique properties of water and do your own experiments? Try out the activity related to this video at the STEMonstrations website. See you next time.
Along with the research that's being done inside the International Space Station's many laboratory modules, the station also hosts experiments that are targeting the Earth. Researchers who are interested in getting a better understanding of lightning and thunderstorms are using the station to study transient luminous events, which are storm-related phenomena that you can't see from down here.
A display of lights above the storm. Presented by Science at NASA. In 2015, European Space Agency, or ESA, astronaut Andreas Mogensen was on board the International Space Station, or ISS, photographing the tops of thunderstorms from Earth orbit. and he saw something very interesting indeed: blue jets. Blue jets are a type of transient luminous event, or TLE, flashes and glows that appear above storms that are results of activity occurring in and below those storms. Blue jets pulse from the tops of intense thunderstorms and reach up toward the edge of space. In January 2017, researchers at Denmark's National Space Institute published their analysis of his observations in Geophysical Research Letters. Mogensen was able to capture clear video as the station flew over the Bay of Bengal, and they were amazed by what that video showed. Olivier Chanrion, lead author of the publication, reported that during 160 seconds of video footage, 245 pulsating blue discharges were observed, corresponding to a rate of about 90 per minute. One of the blue jets observed reached 25 miles or 40 kilometers above sea level. Visual evidence of TLEs wasn't available until 1989. Early evidence included red sprites photographed by cameras on board the space shuttle and photographs taken during a NASA and University of Alaska airborne campaign. Red sprites are glows in the upper atmosphere tied to the presence of large lightning flashes but not attached to the clouds themselves. In recent years, the ISS has afforded astronauts the opportunity to photograph a number of natural light shows produced at the tops of thunderstorms. A 2013 study by researchers from the French Alternative Energies and Atomic Energy Commission analyzed pictures from the NASA Crew Earth Observations Facility aboard the station. The pictures revealed 15 sprites and their parent lightning flashes. In August 2015, the Expedition 44 crew on board the station photographed red sprites over 2 different storms within 3 minutes of one another. First over the American Midwest, and then near the coast of El Salvador. These sprites reached as high as 62 miles or 100 kilometers above the surface of the Earth. All of these studies are contributing to researchers' understanding of lightning and thunderstorms, how they form and develop over time, and why storms produce different TLEs in different circumstances. However, according to Tim Lang, atmospheric scientist at NASA's Marshall Space Flight Center, TLE studies have been, to an extent, fortunate observation. We've gotten better at finding them, but it's mostly case-based analysis. NASA and partner agencies are advancing in their efforts to make continuous storm observations. NASA's Lightning Imaging Sensor, or LISS, was installed on the International Space Station in February 2017 as part of the DoD Space Test Program. LISS on the station is the latest in a line of instruments used to locate and detect lightning over a large region of the Earth's surface. The Atmosphere-Space Interactions Monitor, or ASIM, will be installed outside Europe's Columbus Laboratory on the ISS later this year. Torsten Neubert, ASIM principal investigator, says, the instruments will monitor thunderstorms and their effects on Earth's atmosphere, gathering information about blue jets and other TLEs, as well as flashes of X and gamma rays. LISS and ASIM will be providing data that gives researchers the opportunity to analyze storms from both below and above. All of these studies are adding to our knowledge of how storms evolve and change, helping improve storm models that could lead to better predictions and forecasts. For more science from above the clouds, visit www.nasa.gov/station. For electrifying updates, stay tuned to science.nasa.gov.
A good portion of the scientific research being done on the International Space Station is intended to support future trips out beyond Earth, to the Moon and Mars, and out into the solar system. The people responsible for those projects are just as much heroes as the astronauts who get to go to space.
So you want to go to Mars. What does it take to be a NASA hero? Meet the heroes behind the scenes who make deep space exploration possible. People often think of astronauts as heroes, and they are. And they will be the first ones to tell you that there are many other people who make space missions successful. On Earth, there's ground support, the folks responsible for launch and landing. Heroes work in mission control and keep a watchful eye on the astronauts and spacecraft 24/7. Heroes design, test, build, and fly the rockets and spacecraft that take astronauts off our planet. And there are heroes who make spacesuits, habitats, and equipment for the astronauts to live and work on the Moon and Mars. Human spaceflight is possible because of the heroes on the ground and behind the scenes who build the technology and systems needed to send astronauts into the solar system. Will you be a NASA hero? For more information, visit this NASA website.
NASA's future exploration efforts include development of the spaceship that'll carry astronauts beyond low Earth orbit one day. Major hardware manufacturing is underway to support what is known as Exploration Mission 1, the first launch of the Orion spacecraft using the new Space Launch System rocket and the attendant ground systems. This flight will not have humans on board, but it will pave the way for the missions that will. That Orion spacecraft being developed for future missions out into the solar system is not the only new vehicle on the horizon. NASA's Commercial Crew Program is working with Boeing and SpaceX to get 2 new ships ready to bring astronauts to the International Space Station. In August, NASA Administrator Jim Bridenstine came to the Johnson Space Center for a public announcement of the men and women who will be on board for the first test flights of these 2 commercial spacecraft.
Introducing NASA astronaut Bob Behnken.
I think if you ask any of us as graduates of a test pilot school program, what we wanted to do as the dream job, it would be the part of the development of a new spacecraft.
Introducing Boeing astronaut Chris Ferguson.
There's just something about going to space that has always been special. And I always thought I could satisfy my curiosity by going one time. And I quickly found out that that didn't work. Space is just, there's something magnetic about it.
Introducing NASA astronaut Doug Hurley.
You, as one of the astronauts flying the vehicle, how you interact with that vehicle, whether it's controlling it, whether it's monitoring it, whether it's living in it and getting it to the space station and back. I mean, that's really what we bring to the table.
Introducing NASA astronaut Eric Bowe.
We have simulators now. We have all these things that are mainly hardware, things you can really touch and feel, and you realize it's getting close. And so to me, that's what really makes this time really exciting, is because you can really imagine it now, because you've got the hardware and you know it's going to go into space here shortly.
Introducing NASA astronaut Nicole Anapu-Mann.
I'm most looking forward to launching from American soil, and then when I do get to space, looking back and seeing Earth and seeing America and all the people that have worked so hard to make this possible, and I look forward to sharing that moment with everybody.
If you'd like to get another look at any of the stories we feature today, check us out on YouTube and Facebook at the addresses that are going to pop up there in that blue box. And while you're there, look at all the other cool stuff you can find about NASA and America's human spaceflight program. You should also check out Houston, We Have a Podcast, which features folks at NASA talking about their work in all aspects of space exploration. New episodes post Fridays. Today, September 21st, Gary Jordan talks about the International Space Station and the future of NASA, including Commercial Crew Program and Orion and exploration of the Moon and Mars, in a conversation with NASA Administrator Jim Bridenstine and Johnson Space Center Director Mark Geyer. You can see the video version of that podcast on NASA TV this evening at 7 o'clock Central Time. You can go to www.nasa.gov/Johnson/HWHAP at any time. Find all the episodes there. You can also listen on Apple Podcasts, Google Play, and SoundCloud. This is Mission Control, Houston.